Go back to the Design tab. The interactive column design allows you to examine and alter individual column design in more detail. You can select the column, then click on this icon. Alternatively, you can double-click on GC1. This will launch the column interactive design dialog. Section dimension shows the parameters of the column such as size, clear height, and concrete cover. Steel bars shows the number and layout of the rebar. Corner bars are the 4 bars at the corner. 1 int is the internal bar along direction 1. 2 int is the internal bar along direction 2. Clear spacing of bar, steel area required, minimum and provided, are shown next. Load combination table lists down all the load combination and the design forces. The most critical or governing combination is highlighted in red. Click Interactive Design will redesign this column using the latest settings. The design information will be exposed, showing the critical or governing load combination, neutral axis, slenderness checks. At the bottom, shows the summary of the design reinforcement. Click Design Report. This report shows more detail of the design. For example, at the very end, 3 utilization ratios are calculated. First is the steel area required divided by supplied. Second is the design axial load divided by the axial capacity. Third is the design moment divided by the moment capacity. Close the report. Click OK. Click Column Analysis to show the interaction diagrams of the column. The interaction diagrams shows the possible combination of axial force and moment that cause failure to a given column dimension and rebars. Select interaction diagram N and M. For rectangular columns, there will be 2 capacity curves in direction 1 and direction 2 respectively. The governing design will usually be the smaller curve. For this column in will be along direction 2, the shorter dimension, and hence weaker capacity. This capacity curve shows the maximum axial capacity of a reinforced column is dependent on the coincident or applied moment, vice versa. If you place the mouse cursor in the diagram, the values of N and M will be shown at the bottom. The axial capacity of the column decreases as applied moment increases until the balance point, which is the maximum moment capacity. After this point, moment capacity decreases with decreasing applied axial load. There is also an axial limit to this column, which is stipulated in the selected code. All the design combination forces are plotted and marked clearly in the diagram. For the design to pass, all design combination points must be inside the interaction diagram and below the axial limit line. The interaction diagrams M11 M22 plots the component M1 and M2 moment capacity of the column at a given applied axial load. For example, for this column, this curve is specifically for the axial load stated, which is from the critical load combination. The design M1 and M2 is marked as a dot. Since the dot is within the curve, we can confirm the column passes. Close the interaction diagrams. Click Diagrams. This will show all the force diagrams for this column, including envelope, load cases and load combinations. Exit the diagrams. Save and Report will generate the column design report for this column. Close the report if generated. Reset bars. This will reset all changes of the rebars in this column to the original state. Click Parameters. Here you can change the design method for this particular column.
Currently, the default is bar layout optimization method, as set in the master column design settings. Click Cancel.
Image maximum, minimum. Click to maximize the column diagram. Click again to restore to original. Click Elevation Drawing. OK to include all stories. This will produce the preview of the column elevation drawing. You can zoom and review. Close it. Go to Links tab. If you click on Link Patterns, you can change the link pattern of this particular column. Click Cancel without changing. Go to Shear Design tab. The summary of Shear design is shown. If you wish to recheck the link design, click Calculate to refresh the design. If you wish to manually change the link design, click Edited. Now you can overwrite the default design. However, if you do this, the program will no longer automatically redesign the shear links of this column. You are fully responsible to check the shear design yourself. The Slenderness tab shows the bracing conditions of the column, effective length factors, and additional moment due to slenderness. For this column, it is braced in both directions. The calculated effective lengths, beta, are less than 1. Hence additional moment is 0 or minimal. You can change the bracing condition manually. Untick both direction 1 braced and direction 2 braced. Since design assumption has changed, you must click Interactive Design to refresh the design. Notice that the unbraced condition of the column now results in effective lengths factors, beta more than 1, in both directions.
Click OK.
Go back to Slenderness tab to review. As the column is now slender, additional and higher slenderness moment is calculated and automatically added to the base design moment to become the final design. If you want to manually save either the bracing condition or beta factors, ensure to tick Edited. This means the design module will not auto-calculate the bracing condition or change the edited values anymore. For your information, you can change the column dimensions and clear heights here and click Update. You can then click Interactive Design button to re-perform the reinforcement design. This is handy if a column fails due to insufficient size and you want to try out if a bigger size works. However, due to the change in column size, the weight and stiffness of the model will change. Hence, you should rerun analysis to derive new design forces and recheck the column design to ensure the design is sufficient finally. The column design forces are automatically linked and updated to the latest analysis run. You can overwrite the column design forces manually using the user-defined combination function. To manually enter column design forces, select the first row of column design forces. To select more rows, you can hold down Control key. Let's just select the first row. Pick Select Marked Combination as user-defined. Click Yes to confirm. Click on Figures under N-axial load and enter figures for top and bottom. Example, 1000 top, press Enter then 1000 bottom. Then click on another cell to continue. Pick Select, Unselect All to ensure all the rows are selected. Click Interactive Design to update the design to user-defined forces. Click OK. Untick User-defined loads to auto-link back to analysis forces. You can manually fix the layout and number of rebars and let column design auto-select rebar size. Pick parameters. Pick Fix Bar Layout method. This option ensures that the number of bars will not change during redesign, only bar sizes will be changed to achieve a pass status. Input 2 for one internal, under Quantity column. Press Enter, or click on another cell to refresh. Notice the diagram now shows two numbers of internal horizontal bars on both sides. Pick Select, Unselect All to ensure all the design combination rows are selected. Click Interactive Design to redesign. The column will be redesigned to 8 number of bars as specified. Click OK to close. Click Cancel to exit and discard all changes for this column. Steel Standardization. This allows you to view and change the main rebars of the columns at the same location for all stories. First, click the drop list to locate the column. Locate GC5, the circular column. Next, you can change the rebar. Say change to 16 diameter for the first story. Click Save to save the change. Click Cancel to exit. The rebar for GC5 will be changed in the design screen. You can copy and paste bars easily to other columns. Select GC5. Click Copy Bars. A green equal sign will appear next to the columns, having the same section shape and size. This means that you can paste the rebars to these marked columns. You can paste individually by selecting a column, say 2C5, and then click Paste Bars. The rebars will be pasted and the column will automatically be checked if it passes or fails. The utilization ratio will be updated accordingly. You can also paste all columns of the same size. Click Paste Bars to all. All marked columns of same section size will now have the same rebars. Filter. You can filter by story and member labels. To multiple select, hold down the Control key. Click OK. The columns and walls will be filtered by the selected criteria. This is very useful if you want to focus on certain elements only. If the model is very large, you may want to filter by stories to batch design columns progressively instead of all the columns in one go. Click Filter again. You can filter by section and select the different section sizes. List fail members only is handy to focus only on failed members. List columns or list walls only are self-explanatory. Click Display all members to unfilter all. Click OK. To close without any filter. Delete user-defined loads. This will delete all the user-defined loads entered using the select mark combination as user-defined function entered in the interactive column design dialog. This means all design load combination will link automatically with analysis results. We have now completed the column design. Close the column design window.
Review column design settings. If settings changed, members must be redesigned. Use Reselect bars. Rebars are automatically designed to moments shear. Torsion is not auto-design but check to code clauses. Effective lengths additional moment are auto-calculated, but can be manual overridden. In interactive design, bar size, number can be changed. Ensure no red figures as it indicates failure. Check the interaction or capacity diagram. Ensure all design points are within the curve. Although column size can be changed, rerun analysis for updated forces. Polyline column is for columns with irregular shape. Rebar position must be manually defined. Rebar sizes will be auto-selected in design. Merged wall can to used example to form lift core. Rebar's number position must be manually defined. Rebar sizes will be auto-selected in design. For start, don't merge first but design as separate panels. If separate panels fails, it's unlikely the design will pass when merged. Good idea to design columns progressively as you build model. Manually input column forces to estimate feasible size using marked comb as user-defined. Use filter function to design in small batches, example by story.